So welcome to this session on Industry 4.0. In WCA's PEGASUS benchmarking project, we found that the top plants in terms both of power consumption and heat consumption were plants with significant Industry 4.0 development. And it's increasingly clear that these tools are providing significant performance benefits. So today we're going to hear from three experts in quite different areas. First, we'll hear from Karim of Microsoft, who's going to talk about mixed reality. So this is a technology with almost limitless applications, and one that could transform the way that we run and maintain our plants, as well as the way we conduct our training. And secondly, we're going to hear from Fokion Tasoulas of Titan Cement. And he's going to talk about asset failure prediction with artificial intelligence in the cement industry. And I think Fokion has some very interesting examples of how that has been able to really save significant amount of money and prevent disastrous breakdowns. And then we're going to hear from Feng of Schneider Electric, and he'll talk about advanced process control solutions and the energy efficiency and other advantages that these can bring. Now, all being well, if everybody sticks to the time, we'll have time for Q&A. So Alex, let's start with you. Thank you.
Awesome. What I will do now is I will share my screen and let you know when that comes through. Awesome. Well, hello, my name's Karim. I'm the IoT and Mixed Reality Product Marketing Manager here at Microsoft. I'm here to talk about mixed reality a little bit today, a little bit of IoT, and then just connect that all together regarding the architecture, engineering, construction, concrete industries as best as I can. So yeah, I'll do a little bit of an intro. I'll talk a little bit about data and AI, the journey to net zero, and how Industry 4.0 technologies such as mixed reality and IoT can help. And then I'll do a little bit of a deep dive into mixed reality specifically, what it is, and how it can support kind of heavy industries such as cement. So as a quick intro, like I said, my name's Karim. I'm very interested in mixed reality technologies generally. In my previous role to Microsoft, I worked at McLaren, where I was bringing this technology into automotive and Formula One, which was, to be honest, started a bit of a passion of mine, really, because I was seeing the value of that within the automotive and manufacturing scenarios. And then in my personal life, I bought myself a virtual reality headset, started to get a bit of a better understanding of things. And then now I find myself here at a role at Microsoft, which is really exciting. And I get to kind of work on this technology every day, which is something that I'm very interested in. So where to start? I think the best place to start is talking about Industry 4.0 technologies generally, and then how that then transposes into kind of mixed reality and the value that that adds on top of your traditional technologies. But let's start at sustainability, right? So sustainability is obviously one of the key topics of this conference. It's obviously a massive topic at Microsoft. You know, for us, it's about the ability to meet the needs of the present without compromising the needs of the future generations. And Microsoft specifically is committed to harnessing the power of technology to help everyone. You know, not just ourselves in terms of our own personal commitments to be carbon negative by 2030 and remove all of our historical carbon by 2050, but it's also about providing the industry with the tools that they need to help on their journey to net zero, as it were. And how does kind of technology help? Well, data is now considered as important to UK infrastructure as concrete and steel. And I thought this was quite an interesting slide to talk about, especially considering the audience today. As you guys will well know, cement production currently contributes about 8% of carbon emissions globally, and buildings generally contribute for about 40% of total US energy consumption. So there is change that needs to happen in this industry, and technology, I believe, is one of the key ways to support, really. And we talked about, all right, well, what's the problem statement? Well, how does technology support this? How does it support this journey to net zero, as it was? Well, the first thing is to understand, you know, personally for each organization, right, well, what is our carbon emissions? What's our energy consumption? What is the data that we need? And so the key thing to start then is to start measuring that data, measuring those kind of emissions using then modeling and AI technologies to understand the future of that, and then looking to manage that. Once you know what the current mode of operation is, you can start working and managing your kind of future mode of operation, recording, reporting, reducing emissions, reducing wastage, and then ultimately replacing and removing things from your kind of process chain that are negative, really, effectively. And when we talk about technology generally, and we talk about digital twins, AI, edge, it's very much a journey. Starting with the cloud and migrating your services there to provide globally available unlimited compute resources. Then, when we're talking about measuring IoT sensor information, bringing that computing then to the edge, in certain scenarios, adding AI and this going to the modeling perspective, actually using that to understand your data better, and then model it, and then ultimately build a digital representation of your current state, a digital twin, if you would. And that's Industry 4.0 as a kind of overview of saying, okay, well, the problem statements that certain industries have right now, what's the technology that can support? And I think that journey of cloud to digital twins is something that's fairly well talked about, but mixed reality is very much a part of that whole ecosystem. And I really wanted to talk about mixed reality more specifically today. Well, I've said the word mixed reality about 5 times in this presentation. Well, what is it? Well, for Microsoft, it's about blending the physical and the digital worlds together. So the physical world being, this home office that I spend so much time in now, and then the digital content, the digital world being all of the PDF documents, the 3D content, all of the information that I'm using. And what mixed reality really is all about is bringing those worlds together, and bringing digital content into your real world, your real environment. And, when we talk about mixed reality generally, people then say, okay, well, this is great. We're able to bring digital content into our real space. Well, but what are the enterprise use cases? Where is this actually adding value to enterprises right now? Now, these are the kind of top 6 use cases that we see our customers getting value from mixed reality today. And specific to kind of cement and architecture, engineering, construction, I would like to point out 3 of these. Number 1 being the remote assistance use case, having frontline workers out in the front line with an issue that they need an expert to support with. Now, typically, you may fly someone to that site, they may have to travel there, then you have downtime, reduced production. There's lots of other impacts to that, as well as, the cost and the carbon emissions that are associated with that. Well, remote assistance technology is effectively providing your frontline worker with the tool to connect to an expert anywhere in the world, and for them to get eyes on the problem and support them right at the point of the issue, which is really amazing. Guided task execution, which is another key one. It's about upskilling people, getting people up to speed on their task as quickly and efficiently as possible. If you're a new starter in a role, typically, in some of these heavy industries, you're given a stack of paper this thick of all the kind of rules, regulations, how to do work. You may be given classroom-based training, but when it comes to actually getting someone on the job, guided test execution is effectively bringing digital content in, talking them through what they need to do in real time. And I've got some cool examples of that, which is really adding value, and the time to getting up to speed is much reduced. And then going into the future, hybrid collaboration, right? Bringing people together from around the world in a similar way that we're talking through platforms like Zoom today and Teams, but taking that to the next level, making you feel like you're in the same room and environment as that person, and sharing and collaborating in a more efficient way, which is really amazing. So the power of mixed reality, we are device agnostic at Microsoft. We support phones, we support tablets, but we have a premier headset in the HoloLens 2. The HoloLens 2 is effectively a untethered holographic device that you wear on your head. And effectively, when you have that headset on, unlike a virtual reality headset where you're closed off from your environment, with the HoloLens 2, the glass front, you're able to see through it, but then what you're able to do is then bring digital content into your world. So I will see holograms of certain pieces of information that are useful and relevant to me. And the HoloLens comes in different variants. For cement manufacturing, and for heavy industries, we have a Trimble XR10 variant, which is effectively a hard hat with Class 1 Division 2 certification. So hard hat integrated, it has noise cancelling capabilities. And if you were looking into the mixed reality or the HoloLens ecosystem, that probably would be the device that would most likely meet your needs. We also have an industrial edition with the clean room certifications, and obviously our kind of regular HoloLens 2 SKU, as it were. But that's interesting. These are the use cases. This is some of the technology that you might use. Well, I like to talk about the ROI that kind of our customers are getting, and that's really the value that you'll be interested in, right? So, for example, in that automotive use case where you have remote assistance, well, we're seeing Mercedes-Benz are reducing their travel costs by 40%, right? And if we're talking about the manufacturing scenario where we're bringing digital content in and talking people through a repeatable task, well, by using technology like that, Lockheed Martin have reduced an 8-hour activity to 45 minutes. Those are the kind of highlight statistics that I like to talk about, because it makes a significant difference to the business. And it's not about talking about a cool augmented reality, mixed reality technology. It's about, hey, the efficiencies that this can bring is significant. And, this technology is very difficult to kind of talk through without providing some sort of visual aid. And so we've got a quick kind of clip here that talks about one of the use cases. So I was talking about remote assistance, right? Well, this is one of our products, Microsoft's Dynamics 365 Remote Assist. And what you're seeing here is the frontline worker has the headset on, and they're making a call back to an expert somewhere else in the world. And that expert is effectively seeing through their eyes, seeing the problem in real time. And then what you're able to do then is bring digital content in. You're able to annotate with holographic ink. You're able to bring in PDF documents, Word documents, all of the relevant information that person needs, but it's also in their field of view, right? So they're able to see it as they do their work, and they're hands-free. So it's worth noting the HoloLens specifically is a completely untethered device. So there's no trailing cable or anything like that. It's its own self-contained computer, which is really, really amazing. And then, when we were talking about the guided task execution use case, Dynamics 365 Guides is our other kind of premier first-party application. And what you're able to do with that, as you'll see through this, is the frontline worker, once they put on the HoloLens and they're going through a task, they'll be able to talk. They'll be talked through the task, told what the ideal pressures, the ideal kind of torques for the wrench, as it were, and they're able to see the holograms going into the component. They're able to see the screws actually physically going into the nuts, which is really, really amazing. So as you can imagine, significant efficiency gains to be had with this kind of technology. And then there's one other kind of product or use case I wanted to talk about, which is Cognitive Spark. So they have a remote assistance technology, but it's about connecting frontline workers to experts, as I mentioned, but it has extreme low bandwidth capability. So I can imagine in the cement industry that maybe Wi-Fi connectivity is poor. I know in many other heavy industries, it's not a prioritized kind of technology. But if you're able to run a call with an expert at as low bandwidth as 256 kilobits per second, then you're in business. And that means a 4G hotspot is sufficient to make the call and the expert to be able to support. And then that's really all the content I really wanted to cover today. It's really like a whistle-stop tour of the technology. But if there was one thing I really wanted you to kind of take away for today, when we're talking about Industry 4.0 technologies, you've had a bit of envisioning around mixed reality. But for us, it's about counting the things that matter. And obviously, I showed this slide earlier, but what you really need to be doing when it comes to problem solving in this industry is measuring the current mode of operation, modeling that, using AI technology to understand the future mode of operation, and then managing that, reducing, replacing certain items and processes that are effectively negatively impacting, especially when we're talking about the sustainability conversation. So really appreciate the time that I had today. I know time is tight, so I'm keen to hand back. I don't know, Ian, if you be hand over to the next person, or who's up next.
Yeah, thank you very much, Alex. That was great. As you say, a whistle-stop tour, but I think it gives everybody an idea of what can be done. And I think when we come to the discussion later, that Fokion, you have some experience of using maybe this system or similar systems that we can talk about. So next, I'd like to hand over to Fokion Tasoulas, who's going to talk to us about prescriptive maintenance. Fokion.
Thanks a lot, Ian. Thanks a lot for the invitation. Can you see my screen?
I can see your screen, but it's not in presentation mode yet. It's still in the, editing mode. Yeah.
Great.
Yep, that's it.
Okay, thanks a lot. Thanks a lot for the invitation. Thanks a lot for the time. I'm mostly a technical guy that I have experimented the last years with something totally different, in line with what Alex presented earlier. So what I will try to present today is something that started to us, to Titan Cement, as an experiment. And we rolled it out then in most of our plants in a totally different manner. And now we will see some results. And now we are at the phase that in the next weeks or months, we will have a spin-off company that has nothing to do with Titan anymore to offer this as a service. So just what is all this about is that we have the collaboration between a technical company like us and experts and deep domain experts on maintenance with software, very innovative software coming from other companies that can address all the cement plants in the world, independent of the technology that has been built, either it's Sonoma or FLSmith or whatever. This software can work and the AI can work in the background and provide valuable information about predicting failure. So just one word about the group that I'm working with for the last 33 years of my life. Founded in Greece 120 years ago. We have 14 plants at the moment in 10 different countries, in 4 different areas of the world. More than 5,500 employees, almost 300 million euros EBITDA the last year. And I'm very glad to share with you that we start this journey. It's really a journey. It's not something that happens the traditional cement way that we are used to. It's a journey that we started 4 or 5 years ago. And on the core of this, we have the data. We have the data platform that connects manufacturing suppliers with the end customer through an integrated supply chain and an integrated data platform. And on the foundation of that journey, and that's all this, let's say, achievements, we needed to develop new skills and new capabilities of our people, primarily digital, then to build a new innovation ecosystem, and to have, of course, a new way of working and try to build a new operating model. From the other side, we have the software coming from a partner, Samsung and Samgord. It's a big company that have presence all over the globe again. So what I'm going to talk to you about, and I will not stay a lot on the theory. Most of you are cement people, you know better than me how it works and what are the different stages with different results of maintenance methods from the reactive to prescriptive. Also, all of us know where most of the failures are occurring, in what stages in a plant, at the commissioning and the birth defects to the aging and the regular operations, and to have different, let's say, errors or stresses or defects from usage. One critical slide that a little bit I would like to make a deeper dive is, it's important in our plans to understand and really depict when a failure starts. And you know, and all of you, you know this graph, that if we understand when a piece of equipment starts to fail, then we can easily salvage it. But then if it goes beyond some areas that you see here, if we go beyond this, that we can hear it or we can smell it, so then you, just to give a slide, so if you go beyond there, then we have a breakdown, and then we have big failures that we lose time, effort, production, and all this. And that's critical. And that's not what happens in our control rooms when you have a SCADA system that gives you 100 alarms every hour, every minute, depends on the plant. So a lot of these signals that are in our SCADA systems might go unnoticed. So, and as you probably see here, and you know from your real life, the earlier we identify the failure, the less the cost to repair, and of course, the total cost of this failure. So what we try to do in our operations, we try to move all our systems to predict such failures. And what we bring here is the connection between what Alex described earlier of the data of cement plant, and that's really from where we started at the beginning, is that's a depiction of a cement plant structure from the data infrastructure with sensors and everything else. So what we have here, just to spend a little bit time on that, we have our sensors. A normal plant, an average plant has around 1,800 sensors, different sensors. We collect them through PLCs and then to SCADA systems, and then we have the control room, and then plant users, and everybody can make a deep dive and troubleshoot and control. So what we do after that, we move all this data to the cloud, and we can offline develop solutions with machine learning that we can later deploy at the edge and get all these results. So as I stay here, more than 1 terabyte of data is created every year from this. So it's a very, from this, let's say, process on a cement plant. So it's a very reasonable number of data that we can make AI implementation. So what we do with this data, we can do real-time optimizers with AI, and we can see from the baseline, depending to what system we used earlier, if it was advanced process system or typical process systems like with fuzzy logic. With AI, we can see double-digit improvements, 10, 15, or 20% higher throughput in our assets. So if we focus now in our semi, the system that tries to identify and predict failures, how we do it, we built, as Alex said earlier, a digital twin of the plant. So we combine the structure of all assets and all equipment and the hierarchy with all the data that we have, and we build the so-called digital twin of the plant. And then we can, with AI, evaluate, and also the historical data that we have, we can evaluate what is normal operation and what is abnormal. So 24/7, the system continuously monitors what's going on and identifies alerts, all anomalies. And these alerts, all anomalies, are going to a remote monitoring center. So what is the difference here is that we don't go through all this learning curve to each and every plant. We do all this digital twin building remote, and then we monitor all the events remotely for a remote control center. We have one in US and one in Europe. So we monitor all our plants. And then there is a collaboration, and I will tell you later about that. So keep in mind, we launch the digital twin, and then we have a digital plan of each cement assets plan. Every minute we calculate abnormalities and events that we evaluate and we try to resolve. And this is our one of our remote monitoring centers that we control all the plants from there. So, and then after that, what we have a very structured interaction between the remote monitoring team and the plants on the ground, the people on the ground of the plant, guiding them how to troubleshoot every event and how to close it and save time and money. So what we have in this remote monitoring center, we have the best talent in deep domain experts in maintenance, because you know better than me, most of the failures that we have in cement plants are not, you know, new ones. 80% of them, 90% of them are the same failures independent of the plant and the supplier. It's about vibration, it's about temperature, it's about lubrication, it's about wear and tear. So this team of people that every day they monitor 10, 15 plants, they know very well, and they can guide the local teams how to fix, troubleshoot, and then fix all these problems, and then to provide to the plant management KPIs of these results. So what is this new service? And that's, as we call it, software as a service. offer. With this, we have an inspector 24/7 in all our plants. We have in the background powerful machine learning and AI that can process amazing vast amounts of data, and then they can identify anomalies that historically are out of the perimeter of a normal operation. Then the team can, on the remote monitoring center, can, let's say, access the local teams and through a structured dialogue, they can improve, repair the potential failures and improve the reliability factor of the equipment in the meantime between failures, saving a lot of cost and having the equipment available to produce more. So here I have two examples only of that. This is one of the favor examples that I have. This is when we start experiment with the system. The system in one of our coolers, and you know that the coolers are supported with cooler fans. It gave us an alarm that a motor is going to fail. The people, they said, no, it's not going to happen. So they deleted. Second alarm again, and the motor failed after 15 days. That was exactly what really made a difference in this planet. A lot of people, they thought that we have something here. And another one, just to clarify a little bit what is the difference between limits of alarm that we have in our control rooms. Here you have an ID fan over a mill, and then you have a motor, a pretty, I would say, old one, probably 50 years old. And then we have as an event that alarm in vibrations, and vibrations are picking up in the axle of this ID fan. And this, you can see that these vibrations are below the high level one. So the system could not notice this. So it's below 7 millimeters per second. It's nothing. And then what we did, we went there, we tried to find out, of course, don't see this very clean floor. Thing was covered with dust here. And we found out that was this dumper here to this corner was broken. So imagine if nobody has monitored this and nobody repaired this, after some time we'll have failures in the motor or on the bearings. So what we have seen from the plans that we have implemented internally, we have seen after 2-3 months of implementation, significant higher reliability factors. We went from 93, 94 to 98, or from 90 to 97. We have plants that run for months with 100% reliability factor now in our kiln. And you know, kiln indicates what exactly happens with other assets. We have doubled or 6-fold improvement in mean time between failure. We went to global level improvement on that. And also, we see significant lower overtime in our contractors, in our people, because now we don't have sudden repairs because of sudden failures. And of course, we have significant lower manufacturing costs. Just to give you an indication from one of our plants, that's an annual estimation of the savings. We had almost 3 million savings of our repairs, and we had 3,000 events. That means it's around 10 events per day. So what this software is doing and the remote monitoring center is doing, it can easily implement, and this can be implemented in 1 month, can easily implement a system that has remote monitoring center that monitors your plant 24/7. Then the whole system can be up and running in less than 1 month. And there is behind the scenes AI always running, and there is a big connection and a very good established connection with your teams locally. And there are deep domain experts global level that can guide your people to repair everything much earlier that it will become a problem for your operations. That was, thank you very much, Ian. I try to keep the time shorter, just to have some time for Q&As at the end. Thank you very much.
Thanks, Fokion, and I'm sure during the Q&A you'll have a chance to tell us some of the interesting stories you have about specific cases where this has worked. So now I'd like to move to Feng from Schneider Electric, who's going to talk about the the use of APC, Advanced Process Control, and some of the benefits that you can see from that. So Feng, over to you.
Okay, let me share my slide. Can
yes,
you see the
we
slide?
can see that. Yes, looks good.
Okay. Good morning, everybody. So I'm Feng from Schneider Electrical. In the following 10 minutes, I will introduce our solution called the APC, Advanced Process Control System for Cement Plant. Okay. So in recent years, I always talk about with my current and some cement plant customers, how we build up a digital cement plant. So the answer is different. Every people have their idea, but one concept is common. Is that like you see in the slides, there are 3 main steps to build a digital cement plant. First step is go to automation to enhance the sensor signal automation, sampling and online analysis machine, and automatic precision. This is the first step. Second step is based on this automation sensor and automation machine, you can build the information management system. It's mainly software systems. The third step is go to intelligence. Based on automation and the information system, you can build some intelligence applications. Okay. So Schneider can provide 3 kinds of things. First thing is we provide the connected products, electrical and automation products. Second, we can provide edge control installed in the plant site, okay, like PLC, DCS, and APC. The third level, we can provide some software solutions linked with operation management and asset management, something like that. Okay. This slide, you can see the whole digital cement architecture for a plant. Okay. It's divided by 5 layers. In the bottom, you can see intelligent equipment. Based on this, we can build the intelligent control layer. In this layer, mainly DCS control and the APC system. The third layer is intelligent production. Okay, you can see many subsystems, energy management, equipment management, quality system, logistics, and so on. And based on these 3 layers, you can build layer 4 and 5. Layer 4 mainly ERP system. Okay, the 5 layer is the BI, business intelligent layer. Okay, let's see a success story from China. We call the Gansu Qilianshan Cement Group. We installed the APC, Advanced Process Control System, in this site for this customer. Get very good result. Okay, in terms of saving the core, saving the power consumption, and makes the quality of the clinker more stable. Okay, and the benefit very good. ROI less than 1 year, only 10 months. Okay, because we installed this APC for this site over 5 years. After that, this Qilianshan group deployed another 6 plants installed the APC systems. Qilianshan Cement Group is part of CNBM. Okay, let's talk about more technical. Okay, for the cement expert system, there are 2 kinds of technologies you can see in the market. Okay, one we call the rule-based technology. Another one we call the mode-based technology. Rule-based it depends on the experience from operator or the process engineer, and summarize all their experience and coding in the DCS or PLC system, then control the production line. Another technology is mode-based technology. This not only rely on the experience from operator and the process engineer, it's rely on the historic data from your site, from the certain production line. And based on this historic data, we build the mode to control the production line. The Schneider APC solution merged these two kinds of technology, mainly based on MPC technology, but we also integrate many experience from the site engineer and plus some rule-based control. So from this slide, you can see the APC architecture. The whole system of APC system is very simple. We just installed a APC server on site and use OPC communication with the existing DCS systems, reading the process data and the sensor data from the DCS, then use the module calculating the results, then send out the adjustment commands to DCS. Okay. Our mode can be divided by different process conditions. For example, for alternative Fourier, you can use different control stub mode to realize this control. We use the same. You use the same clan, use the same preheater, but when you use different full, you can use two sub-control mode to control the production line. Okay, this is the result we can see on the right side of the slide. During the APC automatic control period, the parameter of the precise variable go to very smooth. And when the production line operated by the human being, by the operator, the disturber is very high. So to serve the control loop, we are developed some soft sensor. For example, this is one soft sensor. We calculate the free limestone for the clinker. We use data analysis and big data technologies to get this free limestone soft sensor. You can see the accurate is very good, only less 0.1. Okay, in the APC system, there one very important function is how we optimize. We can use the APC to control every variable more stable, but how we optimize? We do this use EMS. We integrate the EMS optimization function into APC systems because there are many KPIs in EMS systems. We use this kind of historic data to go through optimization. And from EMS system, it will calculate when with the best parameter set point, and based on the quality, based on the KPIs regulation. So EMS will send out all couple of parameter set point to APC system, and the APC system will control all the parameter to the best set pointers. Okay, our APC system has another feature. It's a very easy and maintenance systems, because this system have since more than 40 years application histories. So and widely used in many industries, cement, petroleum, chemical, and so on. So it's a very mature system and approved very efficient and have the good result in different industry and different sites. Even in cement industry, we have deployed more than 30 sites in China. The result all succeed. So finally, I just give a very quick summarize for the APC systems. If you want to install an APC system and get succeed in your site, there are 4 things you have to consider take into consideration. First, these systems have to have advanced technologies. For example, MPC, model predictive control technology is a must. Second, you have to select open software platform because APC just only one of whole smart factories. So this system have to be very open. You can integrate this module with other modules. The third part, the third key feature you have to take into consideration is you have to, according to the cement production features, to consider some special conditions. For example, real-time quality prediction and how to optimize the control system. The last feature is you have to consider how to find a qualified and experienced project execution team, because APC is not a product, it's a system. So you have to have the qualified engineer to test and commissioning on site and ensure the good result. Okay, that's my presentation part. And following, we can get some question and make a discussion. So thank you.
Thank you, Feng. In fact, your point there at the end in terms of the qualified teams a little bit leads us back to the use of the mixed reality. So that was a nice completion of that circle. Feng, would you stop sharing and so everybody can see us a little bit larger?
Okay.
Okay, perfect. That's great. We have a question here, and I encourage all of the people who are in the audience there to put their questions in, and as soon as possible. There seems to be a little bit of a lag between you putting the question in and we're getting them here. So do put them in the Q&A as soon as possible. But we have a question here from Rajiv Sadavati, which I think is quite a good one to kick off with. And he asks, so he's coming at it from the standpoint of wanting to get approval for investment in Industry 4.0. And he's asking, well, how would you go about predicting a firm ROI? And I think before we consider the firm ROI, all of you had numbers in terms of the returns that you can expect in your presentations. But I think that the first thing that you would have to do before even thinking about the ROI is to be clear on what you thought you could do with the technology. And Fokion, I know this is something that you've been thinking about quite a lot, because you've thought about Industry 4.0, not just in the way you talked about today with the maintenance, but in lots of areas. And there's an opportunity for cement companies to rethink how they're run and how they do business. Do you want to say a few words on that?
Yes, thank you, Ian. With pleasure, I will do. Look, first of all, I believe that in general, cement industry is in a crossword of a big disruption. And this disruption is coming primarily from decarbonization, having digitalization as an enabler. So in order to try to be on top of these developments, I strongly believe that cement companies should look the whole value chain of building materials and not only what they produce. They need to expand and to try to connect the final customer, and that's the avenue that we're taking, to connect the final customer with us and try them to address in this integrating environment how we can maximize the value that we offer to the customer, in the same time minimizing our environmental impact of that. And this cannot be done without integrating our data platforms, connecting different siloed operations that we have. Cement is different, concrete is different, dispatching concrete is different, pricing the concrete is different, and XYZ. So we need to integrate that, and we need to change our operating and business models in the future if we want to survive and if we want to get out of this disruption maximum value from this value chain. Coming now to manufacturing, we need to address real problems that we want to solve and predict, independent of people, and how we can do it with data. When we started, and you know this, we have talked in the past, we started with an experiment, and we started very small. In such a world that we live today, without data and ROI in such implementations, you cannot start with a big bang and say that I have a big plan to do that. First of all, because it's very difficult to prove it at a big scale. And second, in my opinion, the most important thing is not technology, it's change management. It's how people on the ground, they act, react, like or dislike what is going to come, what kind of competencies and new capabilities they need to build to understand what's going to happen in the future, how we engage them in different steps, how we work with them, and how we build a new model, how we work in the future, how we change the roles. There are no the roles in the cement plant. In our cement plant, some of them are totally different in the last 4 years. The role of the control room operator is playing, the role of automation engineer is playing, the role the manager is playing is different. And this is going to change significantly in the future. So it's not so simple. If you don't have the commitment from the top to go for it, you cannot do a major change. So you need to start building this from the bottom and then to convince all the organization. We had the luck that we, between the ExCom and the board, we built an alignment and at the beginning, so we had better grounds to do experiments, but you need to approach it in different ways. And I believe most important is not technology. Technology, one way or another, you can find. The most important thing is people, is alignment, is top-down implementation, is bringing people together, new ways of working, new teams, agile teams that are from different functions, from different areas. So that's what I learned, at least the last 3-4 years. That's different what I have learned the previous 30 years.
Yeah, thanks, Fokion. I completely agree with that analysis. When we talk about Industry 4.0, we really should be talking about it, if you like, in the same breath as we talk about responding to the climate change pressures or the climate change requirement to reduce and eventually eliminate CO2 emissions. It really has to start at the top management level. You know, this is a reconfiguration of the industry that we're going to see over the next 10 or 20 years. And decarbonization and technology are really at the heart of that. They'll change the way we manage, the way we work. They'll change which plants are competitive. You know, the use of technology can make a big difference in the way that we manage plants. So if you think about plants in remote areas, which many cement plants are, it's difficult to get qualified people to work in those areas. And the technology that Alex was talking about, this mixed reality, of course, it offers tremendous benefits in being able to deploy real expertise to remote sites. So I think it's to get the best out of it, Reggie, if you really have to take it to that top level. But I think maybe one of the things I'd like to ask all of you is, so where to start? So within your own particular areas, are there ways of starting to demonstrate the potential of Industry 4.0 in companies where perhaps the engineers and the technical guys get it, but management at large doesn't? So perhaps, Alex, I come to you first for that question.
Yeah, I think it's a really interesting question. I think, so as I mentioned at the start of my presentation, actually, my previous role was at McLaren, where I was the customer. I was the person that was trying to bring the technology in. And I totally understand your points, Fokion, because getting that executive sponsorship, to getting those people to actually buy into it is absolutely crucial in actually making anything happen. But I think the thing is, especially with mixed reality technology and Industry 4.0 as a wider conversation, if you work in that area, you're very passionate about that technology and what it can achieve. We have to remember as well in that conversation with the executives is that they don't really care about mixed reality as a transformational technology. What they care about is reduced emissions, reduced costs, increased efficiencies. And so I think that you can't start with the technology. You have to find what is the business problem, start tracking how much that costs to not resolve that problem, and then present the solution that you have identified after doing it like a thorough market analysis. So I think the key thing to think about is to not think about the technology too much and what the technology can do, but start with you as an organization. What is the problem? What is the pain point that you guys have, whether it's a cost that is incurred on a considerable basis that could be reduced, or whether it be a process that's just not particularly efficient that could be improved. You start there. And then I would say in terms of the technology, when you start identifying and start getting maybe even small little bits of budget to do proof of concepts and pilots, is to very clearly measure what the impact of that is on your business. And then when you go back to the executive management, you say, okay, well, we've run this small pilot. It cost only a small amount of money to do this small pilot, but this is the impact that this technology could have on a wider scale. So that's the key thing from my perspective, is in that executive conversation, don't lead with the technology, lead with the business problem and the pain, and then how you can transform that. That's my my experience from McLaren, really.
Absolutely. Yeah. Thanks, Alex. Feng, you must also face this problem of companies wondering if it's really worth investing in these APC systems. What's your suggestion on how to get engagement from management on the possibilities?
Yes. So for install APC system, there are some preconditions for the instruments, for example, gas analysis and so on. So also there are some management requirement. When you install the APC system, you have to change your behavior, because after you install the APC system, operator has less work to do, but they have to stand by when the failure occurred. They have to go to emergency control to handle this kind of case. So after that, you can use optimization function for the APC system to go to the best conditions for your production line. Also, you have to, at the same time, you have to maintain your equipment stable, keep your material quality stable. Then the operation system can be optimized. So
okay.
Okay, thank you.
Fokion, in your experience, what was the part of the system that got the most traction with management more generally?
Sorry, can you?
Sorry, just asking Fokion a question here.
Okay.
So thank you, Feng.
Yes, thank
Fokion, you have implemented a broad spectrum.
If you ask somebody asks me from where to start, I will say start first from areas that you have plenty of data, plenty of good data. Because if you start from areas that you don't have data and you try to, philosophize about what you do, you'll be lost. Because when you have data and you have problems to solve, as Alex said, pain points, this combination is incredible. We have in our company now 25 data scientists, and the only question that they reply, because they are with us, is because in manufacturing, at least, and in other areas, we have data. So first of all, we need to have data. Then the second thing that I believe it's very important is the level of ambition that you have as an executive and as a senior manager, what kind of problem to solve and what will be the new status. And I have to report here what really struck our executive and senior management where the improvements that we had with very simple real-time optimizers with AI tools from the baseline. And that's, I agree again with Alex, we need always to monitor and report performance on some KPIs from the beginning to agree that our baseline without any system is 100, let's say, this KPI. Then measure it with the system. What struck our senior management when we saw that the baseline in real-time optimizers in throughput of assets was 100, and we reached 130, 135. The numbers were amazing. The numbers were unbelievable. So what I say here is, don't limit your level of ambition with the mindset that we had in the past, that we are getting, you know, in cement industry, if you get measurable 1%, 2%, 3%, it's a great deal. But think about getting in a sold out market 10, 15% more cement without any CapEx, without any capital. Because these things that we talk here is with minimum capital. It's not precalciners, it's not coolers, it's not mills, it's nothing. So this is a big bet. And all of us, we need to be very careful how to prove that this is a big thing, and how then to build an organization that can sustain this high level of ambition and high level of operation results. And another thing, you have very high results on assets, and then think about integrating them. That's another level. So I believe that's the reason I made this statement. Decarbonization is the really disruptor. Leveraging decarbonization with AI can improve the situation by 20, 30%. And there are researchers, there are articles that they claim, for instance, for energy, that AI can, on top of everything, improve the outcome by 30%. I believe that's the same on cement.
Okay, yeah, thank you. We have one more question here on from Dali Bondar, and he says, in all of digitalization optimization is important. What are the most important parameters being considered to be optimized? Well, it depends a lot, I think. I don't know, Feng, would you like to make any comment in what are the most important things you worry about when you're implementing APC?
The most important things to consider your preconditions. So because it's just automatic control systems, so we don't change the equipment. We rely on the stability of the equipment. Also, this is very important. Also, some sensors, necessary sensors for the production line, because automation control system based on these signals to run in the mode and get final control commands. So this is very important.
Thank you, Feng. Thank you.
My pleasure.
I'm just looking at the time. We don't have very much time left. I think that the points that we could go on this discussion for a great deal longer, and I'm sorry we don't have more time. I think for coming back to Fokion's point on ambition, there's the presentation from CCUC on their smart plant, which shows some of the things that you can implement in a plant. It's really quite amazingly comprehensive. Of course, theirs was a new plant specifically designed as a smart plant. Now, the rest of us have to work with what we have as a baseline, but it does give some idea of the sort of things that can be included. And so I think we should close it there. Thank you very much to all of the panelists, Feng, Fokion, Tasoulas, and Alex. Thank you for being with us.
Thanks a lot.
Thanks for the invite.
Thank
Great
you.
discussion.
All the best. Thank you, guys.